Hello guys, welcome to my YouTube channel. So today we will be solving Leetcode Biweekly contest 143rd problem, that is split array into maximum number of sub-arrays. Pause the video, read the question, then I'll explain. Okay. So what we will have one array nums that will consist of non-negative integers. Okay. Now what and let's say we have any sub-array from L to R. Then for that sub-array we have the score defined as the AND of all the numbers from L to R, that is nums of L and nums of R, L plus 1 till nums of R. Okay, where AND is nothing but this bitwise AND. Okay, now what we have to do is we have to split this array into multiple sub arrays following this conditions. What sorry, yeah, each element should be part of exactly one subarray. We can't have one element into two different subarrays. Okay. And second thing is the sum of scores of the subarrays is minimum possible. So what the question is saying is, let's say if we have some arrays and we split it something like this. This is part 1, part 2 and part 3. The score of this subarray, we know that how we calculate the score. The score will be calculated by AND operation. So basically if it's L to R, so basically let's say this is till 3, then score of this first subarray will be nums of 0 and nums of 1, and is basically bitwise and till, see, let's say this last index was 3, so till nums of 3. Basically this is, and sorry for bad handwriting. Okay, so similarly we will have score of this and score of this. So if the score of this sub is S1, this score is S2 and this score is S3, then what we need to do is S1 plus S2 plus S3 should be minimum possible. Okay, minimum possible. So those are the condition. What, sorry, those are the requirements. What are those? We have to have maximum number of splits, maximum number of subarrays basically, and the score, the total score should be minimum as possible. Now, so the first thing that came to my mind when I saw this question was, okay, so let's say if there is one array, okay, and if I don't divide it in any subarray, so what will be the score? That will be the maximum, or the, sorry, minimum possible score. So if I'll take the AND operation with all the elements, always remember, if we take the AND with two numbers, then that value will always be less than equal to either of this, because we know that if there are, let's say, if let's talk about this. So if let's say we take AND of these two numbers, then we know that the only set bits will be counted, and even if there is a bit set in one number and not in another, that will be discarded. So overall the value will keep on decreasing. So more the numbers you are taking, less will be, or maybe it can be equal, because let's say if a equals to b only, then in that case the AND will not decrease its value. But if it is not, then it will decrease the value. So if we'll take the AND operation of this entire array, then we'll have the minimum score. Okay, I hope that will be clear. So what I am saying is, if we will take the AND of this entire array, then we'll have our minimum score. So our minimum score ms can be calculated as AND of this entire array. Let me write it, AND over entire array. Okay, so let's say if there was if there was 1 0 in this entire array, then our score will be simply 0, right? Okay, if only 1 0 is also there, then the AND operation, if take the AND of entire array, then score will be 0. Okay, so and let's say if this is 1, this is 2 and this is 3 and 4. Now we cannot break such that okay, yeah, one more thing to see over here is that our minimum possible score will be equal to 0. Okay, now we have to split in such a way that the total score, sum of score of each subarray, is should be equal to this, or sorry, less than equal to this. Okay, less than is not possible because we know that this is the minimum possible score. Okay, and if we'll split it, then it's always going to increase the score, because we'll have to add this value and the remaining values, right? So it will always add. If we'll break it, the and value can be increased, and it will overall increase our total score. We know that we have to have at max ms, okay, that is the minimum sum. So our total score of all the subarrays should be less than, not less than, we already discussed that it's not possible to have less than, so it should be minimum score that is equals to ms, sorry. Okay, now what I'm saying is, let's say if, yeah, so for this case we know that if there is 1 0, then we will have to take subarray such that there should be 1 0, because let's say if we partitioned it in such a way that there was 1 0 in this subarray, but no zeros in this subarray, so overall we know that the minimum score will be 0, but this subarray will give positive values, and if there is one positive value, that means it will just increase our total score of this subarray by some positive value. So our total score for this kind of partition will always be greater than 0. Okay, so then it is not a valid partition, right? Because we have to make sure that the maximum or the total sum is minimum. Okay, the total sum should be minimum. Now, let's consider some scenario if everything is equal to 1 or some particular number. So in this scenario, what we have, our and will be equal to and of this entire numbers will be equal to 1 only. So we'll have to split in such a way that the total sum should be equal to 1. But let's see, if we'll let's say if we'll split something like this, then this subarray will have and value 1, this subarray will have and 1, and this subarray will have and 1. So overall the total score will increase. Total score, this total score will be greater than minimum score. So this will also not be a valid partition. So what we are seeing is, if there is only one partition, that will give us the minimum score. Now we have to split in such a way that the score of this portion plus the score of this person, let's say we are just splitting into two half. So the score of this portion plus score of this portion or this subarray should be less than, not less is not possible, will be equal to ms. Okay, it should not be greater than, okay, it should be equal to. And we know that if we take this entire subarray, right? So what I'm saying is, if we would have taken this entire array, then our sum would be like this. For this entire subarray, if it was s3, then we know that if we'll split it, s1 will always be greater than equal to s3, right? Because we know that because of the property of AND operation. Similarly, S2 will also be equal to, greater than equal to S2, sorry, S3. Okay. So we have to somehow select. So let's say if this is this array, we want to partition it in, let's say, three individual subarray. So if we want to partition it in three subarrays, and our score is ms, then this part should produce sum less than equal to at max ms by 3. Okay, this should also be producing ms by 3, and this should also produce ms by 3. That's the case, then what we can do is, if we have three subarrays, and even then, let's say till here only we have three such subarrays. Okay, what I'm saying is, for this subarray, the score was ms by 3. For this subarray, score was ms by 3, and for this subarray also score was ms by 3, but we still have some elements left. So we know that for this subarray we have score less than equal to ms by 3. That means even if we will include this element in this partition or this subarray, then also this score is not going to increase, right? So if we'll start with just one element, so if this is the, let's say, array. So if we will start with this element, then we will have the maximum value if we'll just take this element. If we will take this one, score will decrease for this particular subarray, right? If we'll consider third element as well, change the color. So if we'll consider till here, then score will again keep on decreasing. If we'll go till here, then score will again decrease. So at minimum, it should be, the max score should be ms by 3. So till the point the score is greater than ms by 3, That means that we cannot partition it in three different parts, right? So we cannot partition it in three different parts. So what I am saying, one more observation is here. If I am saying that this array can be partitioned into four different parts, if this array can be partitioned into four different subarrays, sorry, four subarrays, that means it can be partitioned into two subarrays, right? Because we already know that the the AND value of this entire array will give ms, and if we are splitting it into two half, and even then if the sum is still if sum is sum 1 plus sum 2, sorry, score 1 plus score 2 is still equal to ms, that means we can definitely have entire subarray score less than or equal to ms, right? Because we know that more the number of partition, the score will always right, it will never become less. Okay, so from here what we can conclude that if an array can be divided into four different subarrays and the answer is possible, that means for all the subarrays for 3 to 1 the answer will still be possible. So what we can see from here is we can apply binary search. How we can apply? So let's say if we'll consider seven different subarrays. So basically the subarrays will be contiguous, right? So let's say this seven subarrays dot 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 make the entire array. And we know that this is possible. That means even if we'll merge these two subarray, right? If we'll merge these two subarray, then also if this was having score s1 and this was having score s2, then when we will take all this entire subarray, then our score will decrease. It will be either less than equal to s2 or and at the same time it will also be less than equal to s2, sorry, s1 and s2. So because what I'm saying is s1 and s2 will be less than both s1 and s2. So overall our answer will still be acceptable, right? Similarly, if it fails at let's say eighth partition, then for the ninth, tenth, and all the greater number of partition or greater number of subarrays greater than eight will not be possible. So what we know that we can simply check if this particular array can be divided into four parts. If yes, then it can be divided into three to all the smaller number of parts, right? All the smaller number of subarrays. Then what we can do, we can simply have a binary search. And yeah, we know that. Okay, so let me explain a bit. So first we know that, right, that we'll have to have a binary search, something like that. Low is equals to, let's say, low denotes our low, let low will be, let's say, 1, and high will be at max, and low say is that the maximum number or the minimum number of subarrays we can have, that is one, that is entire array, and maximum we can take one elements, that will be n. So we can run a binary search over here, l less than equals to high, or let it uh, take it as low. So let's, low is less than equals to high, we can calculate m or mid basically, that is equals to low plus high by 2. Okay, let's say low plus high by 2. Okay, and we can have, let's a check function, we can check what we'll have to check. We already calculated this answer or the maximum score, we can say, sorry, the minimum score, that we can simply calculate using running a loop for I equals to 0, so I less than n, and ending with all the elements of nums of I. Initial can be set to, let's say, nums of 0. So we'll calculate the value of and for this particular array, then we'll run the binary search. Okay, then we'll pass the m answer and whatever the required that we can pass. And now what will be this check function? In check function what we can do is we can return true or false, so we can simply write bool check. Okay, let's say what is the number of partition, ll m or something like that, and what is the answer, ll, or basically take it as int, whatever you favorable, and what the answer, what is the maximum answer. Okay, and also the array will pass it, and then we can run a loop. How we can run a loop? Will current is equals to nums of 0, and we will run a loop for int I equals to 0, I less than n, I plus plus. How? If current is greater than, what? Answer divided by m. So instead of dividing by m, I am just taking an m over here. If current is greater into m is greater than answer, that means we'll have to keep adding or more elements, so that overall this cur should be, cur is basically nothing, the end of this particular subarray. So we'll keep on adding elements such that answer into m is less than answer. So in this scenario we can simply add cur is equals to cur and whatever the current element nums of I. Okay. If not, if cur is less than equals to ms, sorry, cur into m is less than equal to answer, that means we can have one subarray. We have found our one subarray. In that scenario, what we can do is we can simply increase our whatever the count. Let's say partition count was 0 initially. So let's say have partition count plus 1, and now for the next subarray we'll have to reset this cur value, right? So we can have this cur value should be set to nums of I plus 1. Okay, just a small check we can put over here. If we are already at last index, that is I equal to nums n minus 1 or nums of size n minus 1, then we can simply return. We know that our requirement was there should be at least m subarrays, and we are increasing the subarrays in this p, so we can simply return p greater than equal to m. Similarly, after this loop we can return p greater than equal to m. Okay, I hope this would be clear to you. If you guys have any question, put in the comment section. I'll answer it. I'll attach the code in the description. Okay, thank you guys.